We're going to look at motion detection. I'm going to start with just this video clip because I know it well and it has good motion in it. And if I put in a JIT P window right away, we can get a little preview of this. So basketball moving around, great. I'm going to make a series of objects to work with this video as numbers, okay? So the first thing I'm going to do is use an object called JIT.matrix. And the JIT matrix takes a video and turns it into a very friendly format for Macs. What is video, essentially?
A series of frames played in a sequence?
Yeah, series of images played successively through time. What is a digital image in its essence? What's it made out of? Pixels. What is a pixel?
RGB.
Digitally. It's 3 values, right? Red, green, and blue. It might be 4 if there's an alpha value, right? So then, what are those RGB alphas? And digitally.
Well, alpha is when there's like transparency.
Yep. Yeah, how do we represent them on a computer?
K.
They're numbers. It's all numbers.
Zero.
Okay? It's series of numbers. Right. And usually, depends on the system, usually we're working with 0 to 256 because that's our 8-bit color range. So we could say a pixel is a collection of 4 numbers. A collection of pixels is an image. A collection of images is a video, right? So a matrix is a way to extract the images from a video and turn them into lists of numbers representative of the pixel value information. This is important because we can do things with programming with numbers. We can't do things with programming with colors or pictures right away, right? We ultimately have to reduce it. So I'm going to say JIT matrix for car 320, 240. So I'm giving it the number of planes that I want. And so the way that the Max works with those images, instead of seeing an image as a picture with a pixel that has 4 values, it sees 4 planes, or as many planes as we tell it to, of channels. So it sees the entire red pixels in one plane, all the blue pixels in another plane, all the green pixels in a plane, and then alpha is the 4th one. It's the 4th plane. Connect that there. And for the demo anyhow, I'm going to just make a series of these so that we can see what that actually does to our video. So far, the matrix doesn't actually have any change. We can still see it as a video. The guy with the ball. Okay? Now, since I'm doing motion detection and running a lot of processes on videos are very taxing on your computer. It's very heavy lifting because depending on the size of your video, right, you think each pixel of the video, we've got 4 values. And in this one, I've already reduced the size of the image to 320 by 240. So quick math, 320 times 240 is the number of pixels times 4, the number of values, because there's 4 planes. So if we want to analyze one frame of this video, the computer has to do at least 307,000 calculations, right? So I mean, that's a lot, and that's a tiny video. So the other thing I want to do is JIT change, and all this does is it's going to say from after the JIT change, only pass through the video if the frame is different from the last one. So it's going to do a quick comparison that says if everything's the same, we don't need to run the calculations again. And again, let's look. Same video. All right. Now we're going to start altering. Yeah. Wait, this one? That's just a video clip that I dragged in from here. So now I'm going to use an object called RGB2 Luma. Any guesses on what this is going to do?
Change the luminosity of the colors.
Yep. Exactly. So it's going to take something that is in RGB color space and make it grayscale. So it's going to strip or average the color information together. So it looks black and white.
No, that's not fair.
Why?
I look for that for the
Oh.
last week.
For the last one, yeah, that's what it's called. I don't like to say black and white though, because it's not black and white; it's grayscale, and that's going to become important shortly.
There's some monochromatic filters.
Okay, now we're gonna get into the tricky part. I'm gonna do two things. I'm gonna make a trigger with two L's, which stand for lists. They're lists. They're the formats of the things I want to trigger. And I'm going to connect that to a JIT op. Sorry. JIT op. JIT op stands for JIT operation. So like we're going to do math on a matrix. And the operation that I want it to do is absolute difference, or absdiff. Yeah, so we're going to do an operation, a jitter operation. So a jitter operation is applied to the whole matrix. And the operation could be multiply, it could be add, it could be subtract. We're going to do absolute difference. So what is the full difference between the two values? And so what that does is it looks at every pixel in our image and says, what's the difference? Or it's going to take it takes two inputs, a matrix in here and another matrix in here, and it's going to compare them. Be, okay, first pixel, what's the difference between those? Next pixel, what's the difference between those? And it's going to give us a new matrix that is just those difference values. Why do I want to do this? This is the fundamental aspect of motion detection, right? How do we tell if something is moving or not?
That changes.
Yeah. Right? So if we look at two pictures and something's different between them, we know that either something is moved, provided that our camera is stable and the camera's not moving. Something in the frame is moved, or the lighting has changed. And that can come around to bite us. So what is this trigger list? I said at the beginning, a matrix is a list of pixels. So as far as Max is concerned, a matrix, right, this image that we're seeing, is actually just like an array. It's one array of pixel values. It's not a grid. It's just a long list, and it knows how to splice it. So if I run my matrix into this trigger list, it's going to take first frame it gets and the second frame and output them as lists, but it's going to change the order. So the first frame is going to come out of the second outlet. The second frame is going to come out of the first outlet. Why? As you remember very back at the beginning of the class, I talked about, or the course, Max works from right to left. So this is first. For our JIT op, we want to subtract from the current frame the last frame. That's how we can compare one frame of the video to the last frame to see if anything changed between those frames. If it did, we know something's moving, right? So I'm going to take the second output of the trigger, which is the current frame, and put that in the first inlet of the JIT op, and then the first outlet of the trigger, which is the last frame, and put that in the second inlet of the abstiff. Now it's going to start getting weird. So why do you only see that, like, barely, that shadow or silhouette of the basketball player?
Those are pixels
Is it-
actively changing.
Right.
Like the colors on like the pants and the shirts are like similar enough colors so as not registered as a change.
Right. So this is something that can throw you off, because you think, like, you could see a person moving, but if their shirt is all one color, like your red shirt, it's only going to be able to see the edges because everything in the middle is still the same. All right. So that's giving me a sense of movement. Now, the problem with this can be, I'm using this video, so it's like going to be very consistent. I might want to use a camera or some other kind of sensor to get image data, which might have a lot of noise in it. So a lot of time we put a threshold on what we classify as movement or not, right? Particularly if you're shooting something outside, you want to capture people moving, not the leaves on the tree moving slightly in the background, right? So you can put a threshold on how great of a difference it needs to see before it classifies it as movement. So we'll put another JIT op, but this time we're going to set the operation attribute to greater than. And we can cook in a value like 0.2. But I can also say connect a float to that so I can change where my threshold is. So now let's look at this a bit. Sorry, I messed up. So the op is greater than the value of the op is 0.2. So that looks largely similar. If we say 0.7,
It's not reflected in the video.
thank you. 0.2. Okay. That gives us a similar look, whereas if we say 0.7, we get nothing. 0.5, very little. What's the difference between this video and the other one? It's also, this video is also actually black and white. Okay, this is still grayscale. This is black and white. Because, and again, this is from last class, the greater than operation is evaluating, is it true or false, right? So it's saying if the value of that grayscale pixel is greater than 0.2, make it white. If it's less than 0.2, make it black, right? And if I change this again, 0.4, okay, so now if the value of that pixel, the grayscale value is greater than 0.4, make it white. If it's less, make it black, which gives us this. So this is how we can set how our motion threshold, right? How much does something have to move before we classify it as motion? This is all well and good. It still doesn't give us actual numbers to work with, right? So our final step is to add a JIT.3m object. And 3M, besides being manufacturer of tapes and binders, in Max is going to give us the minimum value from a list, the mean or average value, and the maximum value from the list. So the maximum is going to tell us the brightest pixel, the minimum is going to tell us the darkest pixel, and the mean is the average. So the min and the max is not terribly useful for us because it's always going to give us a black and white pixel because we're using a black and white image. But the average is interesting. So let's take a look at what that is. So it's giving us the average pixel value for the whole image. So it's taking all the pixels, adding them together, all their values, and then dividing by the number of pixels in the image. So in theory, this is a value between 0 and 255. And we can use that to scale it. So depending on what I want to do with this information, another object I can use is the scale object. And the scale is a super important object. It's one of my favorites. You'll use it all the time once you master it. It lets you take a value as an input that you know is in a certain range and map it, basically do cross multiply into another range. So I could say, for instance, this value I know is going to be a floating point number between 0 and 255, and I would like it to be a value between 0 and 1. So input minimum, input maximum, output minimum, output maximum. And now it's going to give me a very small value between 0 and 1. And this is giving me very little information because there's not a whole lot of motion in this video, particularly at the beginning. Okay. So that's fine. Questions so far?
Can we skip some of the steps in between?
these
Luma?
steps?
Like
No.
No, like the Luma part. Like, I could just change the luminosity to like grayscale. But if it's like in red, it would still work the same. Huh.
So I'm not sure which, but somewhere one of these, the JIT 3M broke, right? I might have to give it a particular plane to look at instead of the whole image. And this is just unnecessarily complex for what we're trying to do. You can do other things, like you could do color tracking, like I want to track a red ball in the frame, but that's different. We can look at that a different time. So that's fine. But I want to use a sensor. I don't want to detect motion in a video. I know where the motion is in the video. I can just watch it. So what about using a camera?
But if
Yeah.
this is not something that you can do with this difference with this amount, because I just can't think in.
Yeah.
You have like this medium of where it's very like, nothing can be on them.
Yeah.
Because with the limits, maybe I can communicate things to these kind of things, but with the medium,
So this value is a representation, a numerical representation of the quantity of motion in a frame or in the video, moment to moment. So I could use that, for instance, to determine the volume of an audio track that I'm playing, where a lot of motion makes it loud, and very little motion makes it quiet. I could use that value to control the rate of playback of an audio track, where a lot of motion makes it very fast, plays fast, whereas little motion makes it play very slowly. And some consistent kind of motion makes it play at normal speed. I could do the same thing with video files, adjust the playback rate of a video file. I could use it more like a trigger, where like I only want it to play this video file if the motion is past 12. Right? We use the past object when we did the volume detecting. We can do the same thing for motion. And why am I like wiggling around in my seat? Because it's much more interesting to use a camera than a video as your input. So I'm going to do qt.grab. And there's a few things I need to run my qt.grab, much like a video player. So this is going to turn on a web camera that I have connected to my computer. If I don't have a camera connected, it's not going to work. I am again going to need a QMetro, like we had with qt.movie going. And I'm going to have a few messages open and close. And this basically turns the camera on or off, whereas the QMetro tells it to refresh the frames. So I can turn that on, I get nothing, I click open, still get nothing. It helps if I tell the grab the size that I want it, 320 by 240. Ha ha ha. Can you see what I did wrong? Messages go to the JIT object, not the metro. All right, it thinks, and now I've got my camera. And so now when I do this, right, I've got live input as a measure of motion. I'm going to lower the threshold here. You can start to see we've got some noise. All right, and just as a quick example, let me save this before I lose it. Right. So I could take an audio file, I could add an Easy DAC and some audio multipliers for volume. Put 2 of those in, 1 for each channel. Set that up. And now, so we can't hear anything because there's very little volume. So that's quite low. So I might want to increase the range of my scale, right? So I might say, well, make it from 0 to 2 instead. And the trick with this stuff is balancing your thresholds and your scalars, right? Because every environment is going to be slightly different, right? So like right now, the lighting environment here affects how well this works. There's a lot of factors. Yeah, I'm going to turn this back down to 1 and show you another fun thing. Because, so I said it's detecting motion. It's also detecting light. Now, my computer, the built-in cameras on MacBooks, a lot of the new web cameras have this terrible feature where it auto adjusts for the light level. It's got auto exposure and it has autofocus. When we're trying to detect motion and light level, that's actually really bad because you can see it very quickly adjusting, right? So you see the flash of brightness and then it adjusts, right? But that's also because I'm doing the frame subtraction, right? And it's just looking at 2 frames. So you're only going to see the flash when it happens. The other irritating thing with the camera on your computer is it's only facing one way. You've got computer in your face. There's all kinds of problems with it. So it's nice to be able to have a little web camera for some of your camera stuff because then you can hide the computer. You can do something else with the camera. These, by the way, I love these. The PlayStation Eye camera. You can get them on Amazon for like $7. I like them because they're fixed focus. They have 2 zoom settings, so you can zoom in or zoom out, and they don't do auto adjusting for anything like that. It's a PlayStation Eye. It's very old, but they still make them. It's also very low resolution. It's like 640 by 480, which you might think is bad, but if all you're trying to do is detect motion, or light level, the resolution doesn't matter all that much, right? You're not taking a picture, you're not printing it. It's also got like a top speed of 100 frames per second, which is really good for motion because you want to see change frame to frame. You don't want some camera that's putzing along at 10 frames per second. Right? You're going to lose a lot of information. So let me see if I can get this one going, right? So now I've got two cameras connected to my computer. It's going to be confused. I'm going to open the JIT-Qt-Grab help file, and I'm just going to copy some of this stuff. What do I want? Yeah, I want these. And then down here. So this comes from there, and these go back into the top. And what these things are going to do is let me look at the hardware that is connected to my computer so that I can choose the other camera. So if I say get dev list and get input list, it should populate these things. But it's not. It's only giving me for the FaceTime camera. I'll have to look at that later, but you should be able to get your second camera on there. Questions about using the camera as an input? Okay. Yeah.
How do I import audio again without doing the drag and drop?
Yeah, so the object you actually want to use, right, so that you don't run into this tile disappearing issue, is called sfplay tilde. Much better way to work with audio. I'm actually going to delete all of that stuff though. sfplay was that one.
So play tilde and then write the file name, or?
Yeah, with a map sign. Okay, so I'm going to clean up some of this stuff for the next step. I'm going to go very quickly. I'm going to delete all of our previews. I am going to pull this up to the top. No, I'm actually going to make this a receive thresh. And have a new send thresh. Make that my floating point value for the threshold. And all of this, I am going to go to edit encapsulate, make that a subcapture called motion. And I'm realizing I forgot that I need an output outlet. Sorry. Okay. So now I've got my motion from a very small pattern instead of taking out my whole screen. Because the last thing I want to show you is jit.scissors. And this is where we start getting into fun things. So I'm going to tell JIT Scissors that I want columns let's do 3 columns, and we'll do rows. Let's do 2 rows. What JIT Scissors does is it takes our input matrix or input video stream and chops it up into a grid. So it goes left to right, top to bottom. So I told it a 3 by 2, so now I've got a 3 by 2 grid. So it's just taking that and cutting it up, and I could make these the actual dimensions that I could do the math, divide 320 by 3, and figure out how big these should each be in actual pixels, but I'm not going to do that right now. Because now what I can do is I can take my motion patch, right, and I can do motion detection on each one of those little frames. So now,
So it's like something's in your left frame, it would go ding, and something's in your right frame, it would go like flop.
you got it, right? So now I'm making a lot of motion in the lower left, but very little motion in the other frames, okay? And so just like Joseph said, this is the way, like you can make a visual drum pad, right? Or a sampler, or a trigger system. And the cool thing is that no one ever has to see that, right? Like that can be part of your patch, it doesn't have to be. You can do it just with audio, or just with other videos that aren't the input video, right? These could all be driving another set of videos. That part is up to you, what you do with this information. And you can divide this into 2 by 2, 4 by 6, whatever you want. So your mission for next time is to come up with something that uses motion, camera-based motion as an input, and translates that into control of audio and or video, up to you. You don't have to use scissors, you can. But using that numerical representation of motion to control another aspect of an element. Yeah.
Can you use a scissor picture on like MP4 video fighters, or only?
Yep. Yep. So I could feed a video. I could feed the basketball player guy into that. Mm-hmm. Threshold. The one thing that I would want to look at, right, if I was really concerned with this, in these little motion pixels, right, in terms of thinking about how my computer is running and how fast it's going. In my matrix here, I'm taking a 320 by 240 matrix. I'm cutting it up into 6 pieces. I'm sending it into here, and I'm then scaling it up to 320 by 240. There's no reason for me to do that. Okay? So I should really do that math and make this a 106 by 120 matrix, because that's all it's looking at from the frame. You don't want to have it analyze pixels that aren't there, or that it doesn't need to. Questions about motion detection?
Motion detection, but what was the window thing to prevent speakers from blowing out?
The multiply tilde, star asterisk tilde. Yeah. And that, so like for that asterisk tilde, you don't ever want that to be more than one, because that's when you run the risk of blowing your speakers out. So I had that with the audio going through the left side and the multiplier going in here. I can use an object called clip one dot, and that will make sure, I believe, yeah, I've got to give it two values. Clip 0.1 dot. That will keep my volume from ever blasting up.